Good morning, children. Now I have to start from for 8th standard second lesson, that is force and pressure. So almost the words are related together. Let us see how each one is different from other. How the force is differentiate from pressure. Force is nothing else. It is an external agency act on the body. What is force? It is an external power. Force is an external power Force is an external power, acts on a body and it makes the body to move or to rest. Suppose if our body is moving, the force applies on the object and it makes to stop. If the body is in the resting condition, the force makes the body to move. So what is force? It is an external power which makes an object to move or to rest. This is force is an external power. For example, we are opening the door. So how we are opening the door? By using the force which is present in our hand. The same like kicking the ball. Like that many examples we can see. So force is an external power. So how we can find out the unit of force is Newton. Everything measured by the unit only, no. So what is the unit of force? That is Newton. We have studied already. You have to write only small letter N. Okay, so let us see what are the things. So what is force? It is an external agency which changes the state of rest or state of motion of a body. State means what? Position. Force is an external power which acts on a body and makes the body to move or else to rest. So when the force is greater, the power also will be greater. If you are giving more force, then the body will move better than that. Okay. For example, we can say that force, how the force act on that. If you know, if the ball, if you are taking a ball, the ball is blown with the air. If you are pricking with one pin, it will lose its pressure. Before that, ball is fully filled by the air. So ball is blown. Now after pricking up, just making one prick on that, the air from the ball is flow away and it becomes what? Shrink. The same ball you are keeping on the metal box in the activity 1 using. The same ball you are keeping on the metal and full we are keeping the pins and you are keeping the ball very properly, very slowly on the pins. But nothing will happen. This is because every pin is, though there are many pins, all the pins are giving only little pressure, little force. So this force does not act on the ball and the ball remains as it is. Okay, so force is greater, power will be greater. The force what you are using is otherwise known as what? External power. So force is an external power. Next we have to see what is force? Pressure. So force I said it is an external power. Pressure. Pressure is the amount of force or thrust acting perpendicularly on the surface area. For example, the pressure acting on a perpendicular surface area, that particular area where the force acts. Okay, pressure is the force acting on a perpendicular surface area is known as pressure. Pressure also measured by Newton. Pressure unit also what I said? Newton only. In short, we can find out the pressure by using force by area. It's that is otherwise known as P is equal to F into E. Okay, yeah. That is Pascal, 1 meter. That is Newton meter squared. Now, we are just seeing two factors. One is force, other one is pressure. Force is an external agency, external power also we can say, that acts on a body and makes the body to move or to rest. The unit of force is Newton. Pressure, the same force only acting in surface area of perpendicularly acting on the surface area. அதாவது எங்கே ஃபோர்ஸ் ஆக்ட் ஆகுதோ அந்த பர்டிகுலர் ஏரியாவில் அது ஆக்ட் ஆகும்போது that we are saying what? Pressure, that is force is pressure is equal to force by area, or P is equal to F into A, that can be represented by Newton meter square. We can say the example one calculation is to say the average weight of an elephant is this is simple calculation. Weight of the elephant is 4,000 Newton. Okay, yeah. We said already what is pressure? The force acting perpendicularly on the surface area. Then we have to see surface area where the elephant stands. Surface area that where the 4 feet together 0.1 meter square. Two factors we are finding out. One is weight of the elephant 4,000 Newton. Then where the weight act on that, where the power force act on that, the surface area where the elephant stands, that is 0.1 meter square. Area means what? Squared only. So like that. Okay, yeah. Then we are finding out surface area, all the 4 legs are together. Now we have to find out for first one leg. So 4,000 divided by 4,000 Newton. Okay, yeah. Then area of the sole of the foot is, as per the formula, force is equal to force into area. Force is what? 1000. Surface area is what? 0.1 n. 1 n. (0.1). Okay, yeah. So 0.1 means here 0.1. So because of 1 we have to add one more 0 there. So the answer is 10,000 Newton. 10,000 Newton meter square, or else 10 to the power of 4. Clear, children? So force is an external agency act on the moving object or resting object. Pressure, it is the force acting perpendicularly to the surface area. For example, we are finding out the calculation. So to find out the pressure, we can use force by A. Elephant is 4,000 Newton. 4 legs 4,000 means 1 leg we are calculating, that is 1,000. That we are finding out force by area 1,000 by 0.1. Because of 0.1 area, we are just substituting one 0 there. So 10,000 Newton meter square and 10 to the power of 4 Newton meter square. And many examples we can give for the pressure and force, power, pressure and force. Okay. So more number of wheels are provided for the heavy goods carrier. For example, you see lorry. At least how many wheels are there? The wheels are presenting that to reduce the pressure of the vehicle. So if it is more area, more surface area it's acting, pressure will be somewhat minimized. Okay. For example, I said this one. A more number of wheels are provided for the heavy goods carrier for decreasing the pressure, thereby increasing the area. Pressure is decreased, area is increased. The same like school children, they are wearing the bags at the back. So they got much load on the back, but that can be reduced by the broader thing. The whole பண்ணும்போது அந்த brand இருக்கு பாருங்க, மேலே பட்டையாக இருக்குல்ல, that is broader thing, broader tape, that reduces the pressure and surface will be more and it reduces the pressure on the shoulder. Now we have seen what is force, what is pressure, how the force, next we have to see how the force act on air as well as liquid. Force act on air and liquid. Air is a solid, no, act on liquid. We will see what are the things. The force exerted by the air is known as atmospheric pressure. The force exerted by the air is known as what I said, atmospheric pressure. This atmospheric pressure can be found out by using a special instrument, that is barometer. Whatever the instrument may be, either it is used to find out the pressure or temperature, whatever it may be, it's filled with the mercury. So above the mercury there should be an empty place. In that place only what is there? Force act on that. The empty place is known as vacuum. The very first this barometer was found by Torricelli. So the empty place is known as Torricelli's vacuum. Very first barometer is a device which finds out the atmospheric pressure. The air, that is pressure exerted in the air, is known as what? Atmospheric pressure. That is measured by barometer. The barometer was found out by Torricelli. So what is the mercury is the liquid, that is metal used in the barometer. So atmospheric pressure decreases with the altitude from the surface of the earth. Whenever you are going high, atmospheric pressure is decreases. The persons, those who are going to the space and whatever it may be, they are mountain climbers, scuba diver, whoever may be, they are finding out the atmospheric pressure by using the instruments. By using barometer, they can find out how much deep they dive. Okay. So this is maybe 76 centimeter. The atmospheric pressure may be 76 centimeter or 760 millimeter. Clear, children? The unit of atmospheric pressure is Pascal. So what I say, atmospheric pressure, how it acts on the air. That is atmospheric air, it produces the pressure, that is known as what? Atmospheric pressure. Atmospheric pressure can be found out by barometer, I said. This barometer was invented by Torricelli. Unit is Pascal. Now, how the pressure act on the liquid? That is pressure exerted on liquid. Pressure exerted on air, I said atmospheric pressure. When the same pressure exerted on liquid, it is known as what? Buoyant force. What it is? Buoyant force. We'll see here. Force exerted on liquid. The force exerted on liquid is known as what? Buoyant force. BU. And the process is known as that, together the phenomenon is known as buoyancy. For example, if you are throwing something on the water, we know from the beginning if it is heavier object, it will sink. If it is lesser than the water, the weight of the water, it will float. Okay, yeah. So the floating because of the pressure exerted by the liquid, that is known as what? Buoyant force. Because of buoyant force only, the things are floating on. We have seen the ship, boat, whatever it may be, floats on the water. This is because of buoyancy and buoyant force. The pressure exerted, the pressure depends on, that liquid pressure depends on depth. Depth means, that is, we are saying deep, how deep it is, depth. Okay. So many examples. For example, you take an empty can and you are making 3 holes, that is from bottom, middle and then eye. Okay, yeah, we are making the holes. So then after that you have filled the water in the empty can. So what you have to take? You have to take one empty can, make 3 holes, I said, bottom, middle and top. Then you have filled the empty can with water. The water flows very powerfully from the empty can. So which one will come more powerfully? The hole which is in the bottom. You can see more pressure in the bottom, then in the middle, then at the top. From this experiment we came to know, okay, yeah, that is for pressure depends on the depth. So the last one, bottom is very deep, so it gives more water, it flows more water. Middle one is in middle, so it medium latest. The top one is very less flow of water. From this experiment we know the force, that is liquid pressure exerted by the depth. And many more examples are there. Then activity 4 also the same like that only. So for this you have to take one rubber balloon, take a glass tube. We are taking a glass tube. Both sides are open. In one side that is top and bottom. Bottom we are covered with the rubber balloon. On the top we have to pour water. Then when the water from the top it comes to the balloon rises. Okay, yeah. The balloon start bulging outwards. This is also proves that pressure exert on the depth. Top la நம்ம தண்ணி ஊத்துறீங்க, மேல தண்ணி ஊத்துறீங்க, water ஊத்துறீங்க, that water will slowly come to the balloon. As soon as the balloon reaches with the water, it started to bulge. You know what's the meaning of bulge? From this experiment also we came to know the pressure depends on the depth. And many examples are given there. Next we have to say other example. Here we are taking the same water can or plastic can, whatever it may be. We are making the same holes, only 3 holes. But now we are making the holes in the same height. In the first case, we are making the holes in different height, that is bottom, middle and top. In this case, you are making the holes, the 3 holes in the same side. Okay, yeah. So you have to take punch 3 holes in the side. Now pour some water into the same and see what then making a hole. After that, you are pouring the water, means water will equally gushes out from all the places, because what? Force, you are making the 3 holes in the same depth only. So from all this experiment we came to the conclusion, the force depends upon the depth it exerted. Clear? Next one, Pascal's law. Pascal's law based on force only. Next what you have to see? Pascal law. Pascal's law. What is Pascal's law? That the pressure applied at any point of a liquid in a rest. For example, you are taking water. Water may be in the can or whatever it may be. The liquid in resting condition only. Okay. The pressure applied at any point when the liquid is at rest in a closed system will be distributed equally through all directions in the liquid. For that we can take one rubber ball. Rubber ball you have to fill with water, full rubber ball filled with water and closed. Then after that you have to make many holes through the ball. The water will gushes out from all the balls equally. Because you are giving external pressure, by pricking you are giving external pressure, that pressure makes the water to move in all direction, and this is known as Pascal law. You have to learn what is Pascal law means. That the pressure applied at any point of a liquid, the liquid is at rest in a closed system, it will be distributed equally through all the directions of the liquid. So what are the applications of Pascal law? What are the applications? What are the uses? By using the Pascal law, that is based on that, the automobile service station, that's the place where the water wash we are giving now. The automobile service station, the vehicles are lifted upward using the hydraulic lift. By using that, how cranes are lifting the heavier objects on the roadside. The water thing, the automobile stations, we can lift the vehicles by using the hydraulic lift. Hydraulic lift based on the principle work on the principle of Pascal's law only. Then automobile brake system works according to Pascal law. Then hydraulic press also we are using to compress the cotton bundles. Many cotton bundles are there. It seems to be very heavy, you know. By pressing the cotton bundles, we can make it of soft, less weight. So for that also what we are using? Hydraulic press. So now this lesson we have seen force. Force is an external agency, acts on the moving of body or resting body. Pressure, I said that particular force act in a particular surface area, perpendicular in the surface area. I said an example how the elephant. Then we have seen what is atmospheric pressure, what is liquid pressure, how the pressure exerted on liquid, and what is Pascal law, what are the uses of Pascal law. In the next class we have to see what is application of surface tension. We will continue in the other class. Thank you.